Now let's discuss how different materials behave differently in the content of electricity. Materials can be classified by how well they allow charge to move. Conductors are materials in which electrons can move freely throughout the material. Most of the metals falls to this category, like copper and silver, gold. Because of this, if you place a charge on one part of a conductor, it will quickly spread out and distribute itself over the entire surface. The opposite of conductors are insulators. In these materials, like glass and rubber, all the electrons are tightly bound to their atoms and cannot move freely. Therefore, when you charge an insulator by rubbing, the charge stays in the specific area that was rubbed. It does not spread out across the material. Between these two extremes are semiconductors. Their properties are intermediate between insulators and conductors. Materials like silicon and germanium are famous examples. What makes them so incredibly useful in technology is that their electric property can be precisely changed by adding controlled amount of impurities, a process called doping. Now let's look at the methods of charging. The first is charging by induction. This is charging by direct contact. In this example, a negative charged rod touched a neutral conducting sphere. Some of the excess electrons on the rod move over to the sphere. When the rod is removed, the sphere is left with a net negative charge. The key point is that with conduction, the object being charged ends up with the same sign as the object doing the charging. A second method is charging by induction. This process allows you to charge an object without touching it. First, a negative charged rod is brought near a neutral conducting surface. The free electrons in the sphere are repelled by the rod and move to the far side. This leaves the side of the sphere close to the rod with a net positive charge. The charges have been redistributed. Continuing the process, the region of the sphere near the rod now has excess of positive charge, while the rod is held in space. A grounded conducting wire is connected to the sphere. The ground acts as a massive reservoir for electrons. The repelled electron on the sphere now have an escape path and will flow from the sphere into the ground. To finish, the ground wire is removed, trapping the net positive charge on the sphere. When the negatively charged rod is finally taken away, the excess positive charge on the sphere repel each other and distribute themselves evenly over the surface. Notice the result. We use a negative rod to give a sphere a positive charge. Charging by induction leaves the object with the charge of the opposite sign. The same principle can be applied to insulators through a process called polarization. In a neutral atom or molecule, the center of the positive charge and the center of negative charge are in the same place. However, when a charged object brought nearby, it can cause these centers to separate slightly. This results in one side of the molecule being slightly more positive and the other side being slightly more negative.